Vector algebra operations. Let's talk about what are the different calculations or the different operations that we can do with vectors. And so there's a couple of things that we want to make sure we can distinguish between. So we're going to be talking in this section about, in this little video, about vectors, but we're also going to be talking about something called scalars. And so what is a scalar? A scalar is, simply put, a real number. And so they can be positive, they can be negative, they can equal 0. All of these cases are, possibilities for scalars here. And the idea is that when we deal with these scalars, they're going to be used to scale our vector. And also we should be clear, what are the kind of operations we want to be thinking about. We want to think about addition, we want to think about subtraction, we want to think about multiplication. So we'll talk about all three of those concepts in this video. So here is our definition, our main definition for this section. So suppose that we have U is U1, U2, U3, V is also a vector, V1, V2, V3. I'm writing these out as vectors in 3 space. This also works if we just are looking at vectors in 2 space. So let U and V be vectors with K be a scalar. So we have our first thing here is vector addition. We want to add together U plus V. We simply add together the components. U1 plus V1, U1 plus V1, U2 plus V2, U2 plus V2, U3 plus V3, U3 plus V3. And then our second case here is scalar multiplication. We want to multiply K times some vector U. What do? We take the entries of U and scale each one of those entries by the scalar K. Let me make one very important point here, which is that we have vector addition, we have scalar multiplication. We right now do not have a method, we do not have a definition for how to multiply 2 vectors together. That's going to be the subject of the next couple of sections of the book. And there's going to be, as we'll see, multiple ways to do vector multiplication. We'll need to be precise about what we mean by multiplying 2 vectors together. Okay, so these are formulas. Let me also draw some pictures here. And one more thing is worth me noting is that if we want to subtract 2 vectors from each other, it would simply be U1 minus V1, U2 minus V2, U3 minus V3. So just subtract the corresponding components just as you would want to happen. Okay, so let me draw some pictures here just to say what's going on. So if we have a vector U here and a vector V here, we add vectors together using what's called the Parallelogram Law. Parallelogram Law. So the idea here is we're drawing the vectors, so they're starting at the same point. We take this vector V and translate it up here. We take this vector U and translate it over here. And we form this parallelogram. And so I have one color left here. This is the vector U plus V. So graphically speaking, this is what's going on. In terms of, so that takes care of vector addition. I should also do a picture for scalar multiplication. So if this is U, So if we multiply u by, say, 2, we're just going to have a vector in the same direction as u, but twice as long. So this would be 2 times u. This would be 3 times u, 4 times u. Keep on going. Of course, we could have a fraction, that something like this here would be like 1/2 times u. Also, we should be clear, as we said back on this slide, our scalars can be positive, negative, or 0. So what happens in the negative and 0 case? If this here is u, negative 2u is a vector that's parallel to u, that's twice as long, but pointing in the opposite direction here. So this is u, and this is supposed to be twice as long as u in the exact opposite direction. And then in the 0 case, if this is u, well, 0 times u is just going to be the 0 vector. Okay, those are some pictures. I talked about vector addition, scalar multiplication. Let me do one last picture for vector subtraction. So if this is u and this is v, and we want to do u minus v, the idea is that we want to construct it in such a way so that v plus u minus v gives us u. So what do we do here? If we do v, and if we form a little triangle here. So this vector right here, this is going to be u minus v. v plus u minus v gives us u. Okay, that's pictures for all 3 of those basic operations. Let's do some calculations. Here is this slide here. So let's just quickly bang out some of these calculations. Okay, if u is -131, v is 470, 2u plus 3v, we would just construct that by doing the first component is twice the first component for u, plus 3 times the first component for v, so 2 times -1 plus 3 times 4. The second component would be 2 times the first component for u plus 3 times the second component for v. And then 2 times 1 plus 3 times 0. And this crunches out as 10, 27, and 2. We want to do u minus v. Let's just subtract them component by component. -1 minus 4 would be -5. 3 minus 7 would be -4. 1 minus 0 would be 1. And then finally, so the magnitude of 1/2 u. So what is 1/2 u? Let's do that calculation first. So the magnitude, so that would just be scalar multiplication. We multiply all the entries here by 1/2. So magnitude of 1/2, sorry, -1/2, 3/2, and 1/2. And this would be square root of -1/2 squared plus 3/2 squared plus 1/2 squared. Let me extend out that square root. If you crunch this out, square root 11 over 2. Okay, so these are our basic vector operations here. And to wrap up, to wrap up this video here, I want to show off that we can make just a big chart here, all these properties of vector operations. So u, v, and w are all vectors, a and b are scalars. U plus v, we can write that as v plus u. So this would be commutative. This would be a commutative law. We also have an associative law that we can group these together. U plus V plus W we can do as U plus V plus W. So that would be associativity. U plus the zero vector, anything plus the zero vector will just be that original vector. U plus negative U gives us a zero vector. The zero scalar, this isn't the zero vector, this is the zero scalar times any vector gives us the zero vector. I already wrote that right there when we were doing the scalar multiplication parts. 1 times any vector gives us that vector. And then to do a little bit of scalar multiplication rules down here, A times B times U, we can group that together. AB times U. A times U plus V here, we have a distributive law. A times U plus A times V. And A plus B times U, AU plus BU. So yeah, there's a lot of calculations to do here.